applications on cloud environments like Google Colab. We use C++ standard thread to manage two independent host threads. Each thread controls a separate GPU device context using CUDA set device. If only one physical GPU is present, both threads targets zero dynamically while maintaining isolated memory allocation. When kernel launches, synchronization between turns is managed safely using a standard mutex. The parallel CUDA kernel, evaluate mouse kernel. Let's look like line 14. In this, evaluate mouse kernel. Evaluate mouse kernel. Instead of loop on the CPU, we launch 9 parallel CUDA threads, one for each cell on the board. Each thread independently checks the board array. If a cell is available represented by 0, it calculates a mouse coding using 10 minus 10 index. If the cell is taken, it assigns a score of -1. Host thread and worker loop. Let's move on to line 26. The GPU play worker. The GPU play worker. This function runs on each CPU thread. When its players 1 or players 2 turn, it copies the global host board array to device memory using CUDA memcpy host device. Next, it executes evaluate kernel lesser than 1. Evaluate kernels lesser than 1 board running on all 9 evaluations concurrently on the GPU. Memory management and synchronization. Let's move on to line 89, script the main function. The main function, we detect available CUDA devices using CUDA device count. We then span CPU threads T1 and T2 representing GPU player 1X and GPU player 2O. A shared mutex board prevents race conditions when writing moves back to the shared board state. Live terminal. By executing the code, it will writing a main file in the main.ceu by overwriting it. When you use the compiler to run the code, it will execute the game, the current board state like XOS, like the Tic Tac Toe. Each horizontal and vertical and diagonal is the players to win. The game is drawn and no mouse is left. If you execute it again, the position switched. The game again draws. That's all.